So classified paper from topic 1, which is about the states of the matter. I prefer that you all try to annotate on the screen or use a chat, or you can also use your mic to answer the questions. The graph shows how the temperature of a substance changes as as it cool over a period. Whenever the temperature is constant, like in this region, the temperature is constant, and this region also temperature is constant. So what does it mean? It means the state is changing. Twice the temperature is constant. So here we will have a gas. Here gas is turning into a liquid. Then we have a liquid. A liquid is turning into a solid, and then we'll have a solid. This is a cooling curve. So the particles in the substance have the most kinetic energy. Most kinetic energy means they should have the very high temperature. So S is having a very high temperature. The particles of a substance that are furthest apart in gas, we have particles far from each other. So that will also be S. Substance which exists in both gas and liquid. Gas and liquid means like a state is changing from gas to liquid. So this region V. Then we have to estimate the freezing point. Freezing point means when a liquid is turning into when a liquid is turning into solid, so that is a freezing point. So when we draw the line, so this line is not 150. So you cannot say 150. 150 is not correct. Why? Because if it was 150 or 152, it should be above 150. But this horizontal line, it is below 150, so it cannot be 152. So 152 is not correct. Then if you estimate, because you have to estimate, so between 100 and 150, so this will be 125. So means this could be any value from between 125 and 150, like 137, 140. 125 also you cannot mention 125. Why you cannot mention 125? Because 125 is not exactly, it is not exactly at the center. If it was exactly at the center, when we draw the line, the horizontal line to know the freezing point, so it is near 150, but it is not exactly 125 is this value, in between will be 125. So it is above 125. You can say 130, you can say 140, any number, but below one, it should be between 125 to 150, any number. And it is an estimation. So in estimation, their range of answer will be there in the marking scheme as well. You won't get a fixed answer for this. But it cannot be 125, neither it can be above 150. Name the change of state directly from a solid to a gas. So when a solid directly turn into a gas, what we call sublimation. When a smoke is viewed through a microscope, the smoke particle appear to jump around. What does we call a Brownian motion? But Brownian motion or a random motion in chemistry, it is removed from the chemistry syllabus. So, and why this? So these two parts, D1 and D2, are not part of the new syllabus. But in physics, it is there. Like, for example, if the same question was there in physics, why the smoke particle move in this way? So you'll mention the lighter air molecules collide with heavy smoke particles or dust particles if it was a dust, cause random motion. So Brownian motion is not part of the syllabus anymore. But in physics, it is there. So in physics, you can find a question of Brownian motion, but not here. In question 2, matter can exist as a solid, liquid, or a gas. The arrow shows some changes in the state. Name the change of a state represented on the diagram. What we call a solid is turning into a liquid, we call melting, right? Then in B, a solid is turning into a gas. So when solid directly turn into a gas, we call sublimation. Why energy is supplied to turn the liquid into a gas? So energy is needed to break the bonds or overcome the attractive forces. That's good. Overcome the attractive forces between the molecules. The diagram represents the same number of the molecules in two containers D and E. Which container will exert a high pressure and why? So E is right, that's correct. E, but why? More particle, less space, or you can mention in terms of collision. Less volume, so more collision, often they will collide. So greater number of collision, as a result, the pressure will be high. So this was topic 1.